Driving Change, BioMedTec Science Campus Lübeck.
Welcome to the BioMedTec Science Campus Lübeck in the federal state Schleswig-Holstein. Close to the Baltic Sea, you can find an excellent and rare science landscape consisting of the University of Lübeck, the University of Applied Science Lübeck, the University Hospital, Fraunhofer Research Institution for Individualized and Cell-Based Medical Engineering, and the Leibniz Center Borstel. We are an interdisciplinary, innovative campus, all close together and connected. The campus covers the entire chain from basic research to applied research and clinic to market. The establishment of the Artificial Intelligence Center was another important step for research at the campus. I am pleased to welcome Professor Martinez, Director of the Center. What is the focus of the Artificial Intelligence Center and what goals are you pursuing with it?
The University of Lübeck has a long tradition in medicine, but also has a very strong computer science department. And for a long time now, we have been active in artificial intelligence in connection with medicine. So 2 years ago, we established the center where now institutes from the computer science in basic research, applied colleagues, and also the colleagues from the medical faculty are now under one umbrella. And the center now consists of 34 institutes and clinics, half from the computer science, but also the other half from the medical faculty. And our goal is to bring these two most important parts of the university together and to foster innovations and research projects. And now we already have a couple of very big research projects funded by the federal government, German federal government, and also funded by the state. So it was a very good start, and I think there will be a lot which will come out from that.
What kind of project?
These are mainly projects. For instance, we have one big project where different topics are covered, but it's all medical and artificial intelligence coming together, for instance, in radiology or in neurosurgery, and companies are involved, big companies, smaller companies. So we now are establishing a whole ecosystem for medical applications of artificial intelligence, where different steps are covered, like methods, like the data problem we have in artificial intelligence, regulations are covered.
Okay.
So we all learn together these different aspects which are important for artificial intelligence in general, but in particular also these special applications in the medical domain.
Okay. Is the AI Center also open to companies? It sounds like this because you just told us. And how is your collaboration with industry? How welcome in the alliance?
Very welcome, of course, and we have a couple of projects already. We are offering infrastructure for industry, like special purpose AI software and special purpose AI hardware, which can be used also by industry partners.
Oh, okay.
And of course, we are very eager to bound companies. We have a very strong medical technology company ecosystem in the north of Germany, and we offer these know-how and these different instruments for the companies to learn from it and also to somehow profit from it.
Okay. So companies, you should phone him. Mr. Martinez, you are also the director of the Institute of Neuro and Bioinformatics at the University of Lübeck. How important is deep learning in imaging, and what research are you currently working on?
So our institute is interested in how the information processing is done in biology and in particular also in the brain. And this is a field which has gained a lot in the last 20 years, And we have learned a lot in the last 20 years. And one of it are these deep networks, which are from the structural viewpoint, are close to what is used in the brain by the neural networks we have there. And in the last 10 years, there was a huge step forward by making these networks deeper and larger, and the hardware development supported it, and also the big data which is needed to train these networks. And this was a quantum loop in image processing. Many tasks which were difficult in the past now can be solved, and this is not only in image processing, the same is also in language, natural language processing, where we have made very, very deep and very large progress compared to 10 years ago. And but still, there's a lot we can learn from the brain. These networks are able to solve certain tasks, but they are not really intelligent in the sense our brain now is still able to bring out intelligence, and there's still a lot we have to learn to make artificial systems really intelligent.
Oh, that sounds very interesting. Thank you very much for answering our questions, and good luck for all your ideas and projects you are working on. Thank you very much.
Thank you.
I would like to welcome another interview guest. Welcome, Nele Blum. You are a research assistant at the Institute of Medical Engineering at the University of Lübeck, and you are doing research in the field of medical imaging. What is your background? And what exactly you want to find out? And which role plays artificial intelligence in that context?
Hello, and thank you for having me. I studied medical engineering at the University of Lübeck, and doing my master's degree I spent 1 year in Kiel at the company ZKIL, where I also did my master's thesis about 3D puzzle algorithm and rearranging 3D bone fragments. Afterwards, I started as a research associate and as a PhD student to make my thesis also. And there I researched mainly on computer tomography in the field of image reconstruction and mainly in the field of reducing matter artifacts. Yes, AI plays a role whenever our standard approaches reach the limit due to when we have limited data of physical limitations, and for matter artifacts, for example, when matter objects, we have projections that are corrupted by these high density objects, and so we have a loss of information. And this loss of information is especially the case when we have low radiation doses, and this on the other hand is of course good for the patient. So we have like a compromise of radiation dose and a good image quality. And there's where we can use AI. And another aspect is of course that we have an increased number of databases which are being created, and also we have an increased computational power, so we are able to use these networks on our problems.
Okay. What goal are you pursuing with your research?
Yeah, I try to reduce artifacts in the image mainly, so we want to have an image with low noise, no patient movements and less matter artifacts. And also for matter objects, again, we have the problem when we have like diseases or tumors which are close to the matter object that we want to detect them. And when we have these artifacts, it's not often not possible. So we try to use here enhanced image reconstruction and use also new methods like deep learning to get rid of these artifacts.
Okay. And what are you doing to take part in alliance research?
In computer tomography, we are able to visualize the inner structures of different objects. And this is not only the case for clinical applications, but also for industrial applications. So here we already work with different industrial partners, and of course we want to have new cooperations as well. And another aspect is that we also can transfer our current knowledge in algorithms and optimization strategies, and of course also especially AI, to other fields of interest. So not only the field of image reconstruction, but also like image processing. And I think this is something we can do, and I hope that we find new cooperations.